Assalamu alaikum. How are you? Fine. Can you hear me?
Yes, sir.
Okay. Okay, so what we have covered in the last class on Saturday, we have started chapter 2, right? And then we have covered 2.1, section 2.1, and some parts of section 2.2. The later parts of section 2.2 is covered by today. So in 2.1, what we have covered, the principles of network applications. So we said that network applications are implemented in end systems or hosts, and this is related to network A's, right? Network A's of the internet. And then we have also discussed about two architectures or paradigms working in network A's when we work with network applications. Okay, let me just review a little bit what we have covered. Wasiul, are you there? Wasiul Haq?
Yes,
Wasiul?
sir.
Okay, can you tell me what are the two architectures or paradigms in network A's or using network applications that we have discussed in the last class? Just the names. When you use any network application, it must be within one of those two architectures. Can you remember?
Sir, মনে পড়ছে না, sir.
Okay, you can open up. Everybody can open up your class note, no problem. Your workbook, your notes. When I ask questions, you can see and then tell me, no problem. It's not like you have to memorize. Ifat Ahmed, are you there, Ifat?
Sir, আছে sir.
No answer. Okay, Ashik, Ashikur Rahman. Ashik, are you there? Azizul Hakim.
স্যার আমার একটা মনে আছে ক্লায়েন্ট সার্ভার।
Very good, very good. Client server. Actually, most of the applications we use is client server, where there is a dedicated server. And for example, when we do web browsing, our browser is the client, and then we communicate with the server. For example, Google server, Facebook server. I think another one should be available now. Maisun, are you there? Rubayat,
Yes, sir.
can you tell me the second one?
Sorry, sir, I could not give you the last class.
One is client server. Another one is what?
Sir, I cannot remember, sir.
Okay. Okay. Do you take notes during the class? Also, as I said, you can open your workbook, or you can take your notes. Otherwise, it will be really hard to follow, right? These are all especially in application layer, we all using applications. We are reading about applications, all the applications we are using every day, right? So if you can connect your experience with your with the learning here, I think it will be easier to remember. Saudia Hawk, can you tell me what is the second one? Also, you can use your notes, no problem. You can see the workbook, you can give the answer. Saudi, are you there? No. When we are in the class, we should be always available. Yes, Saudia, can you tell me the second one? One is client server architecture. What is the second one? Okay, who can tell me? Partho, what is the second one?
একটু দেখতে হবে স্যার আমি।
Okay, when you are in the class, you can keep it open. You can keep it keep your notes open, you can keep your workbook open, you can keep your book open, no problem. Shomik, can you tell me the second one? First one is client server, second one. Okay, second one is peer-to-peer, right? It's a very simple, because whenever we use any application, it must be within the client server protocol, or it must be a peer-to-peer. Peer-to-peer means every host can act simultaneously as client and server. And we have given one example yesterday. What was the example? Torrent, right? We all use torrent, so we know torrent is an example of peer-to-peer. Anyway, so these are the two architectures. Any application you use in internet, any application, that must be either in client server or in peer-to-peer, or there is another one that is called hybrid, that uses some properties of client server, some properties of peer-to-peer. For example, I have given one example of this Google Meet, then Skype, instant messenger. There are many protocols where there is a dedicated server, but again, clients are communicating directly with one another. When we send message, we can communicate directly one another. Okay, that was one part. Then also we have covered some of the examples of application layer, and we have defined that there are 4 things every application layer protocol must define. Okay, what are those 4 things? Ishrat, are you there? Ishrat Jahan, are you there? Ishrat? Okay, Shomik, your network connection is not working, but please fix this. This should not be always, because I can see I call many students, I don't get their response. Maybe they have microphone problem, maybe they have others problem, but this should not occur continuously. Jahara, can you tell me at least 1 or 2 elements that must be defined in any application layer protocol? We have mentioned 4 different things. Can you tell me 1 or 2? No?
Sorry, sir, I can't.
Okay, Sultan,
Sorry, sir.
Nayon, Mustafa.
সরি
Are
স্যার,
you there?
আমি স্যার সিক স্যার, গতকালকে স্যার ভ্যাকসিন নেওয়ার পর থেকে স্যার প্রচন্ড গা ব্যথা জ্বর।
Okay, no problem. Actually, we have discussed about 4 things. One was types of messages, right? We have given example of HTTP that actually defines 2 types of messages. One is request and one is reply. Then there was syntax, message syntax or grammar. Then message semantics, and lastly it was rules or actions. So any protocol we have learned in chapter 1 with 3 keywords, defined protocol with 3 keywords, format and order of messages, and then actions. In this chapter we are redefining that definition for any application layer protocol with all these things remaining, but it is redefined as 4 things: types of messages, message syntax, grammar, then message semantics, that means meaning of each field, and then finally rules or actions. Okay, one other thing we have discussed, because application layer is dependent on transport layer, so application layer will select which transport layer service it wants, and transport layer gives 2 types of services. One is TCP, that is reliable. One is UDP, that is unreliable. TCP is connection oriented, there is a feedback, so TCP gives more different services like flow control, congestion control, and UDP is used for faster service, so UDP normally does not provide any feedback, so it will not provide congestion control or flow control, but it will work faster. And also there are 4 points we have decided on selecting transport layer service. That was data integrity, like loss of data, then timing, then throughput, and then final one was security. Okay, and then we have covered section 2.2 where we have started about the hypertext transfer protocol for use for web browsing. And then a website consists of web pages. Every web page is a collection of objects. We have seen there are two messages, one is request and one is response. We have seen the structure of the messages, and then the methods, different type of methods used for HTTP request, and then the format of the response. So that was we have covered yesterday, and now today we'll start from there. And there is one more thing. I will upload one first homework assignment by end of this week. So please keep in mind it will be on chapter 1 and 2, and there will be a deadline. You should get at least 7 days to do it, and then submit in the ELMS only. But I am yet to upload. I am not uploaded yet, but keep an eye. I will upload it, and as early as possible I upload it. Please start working on homework 1. And second point is, you all know our next class test 2 that will be again online. I have mentioned before on 7th August, Saturday. The syllabus I have specified here, and I have also uploaded this class outline to the ELMS already. But let me just mention the syllabus. That is section 1.5, layering concepts from chapter 1. And then two sections, section 2.1 and 2.2. 2.2 we will finish today of chapter 2 up to web and HTTP. That means end of section 2.2 will be included in the class test. So if I do some of the examples tomorrow, that will be also included in the class test. So class test will be up to 2.2, and we'll try to cover the rest of the theories today. That is 2.3, email, different protocols in email, and 2.4, domain name system, if we can, in today's class. And tomorrow we will mainly work with some examples and hands-on. Okay, so this is the overview of today's class. Now let us start our lecture from where we have finished yesterday. So we have finished up to this point, right? We have learned about different format of HTTP request and response, and then we have mentioned some of the response and status codes. Some of these are very common to us, like 404 not found, 301 moved permanently, 200 OK normally we don't see, because 200 OK means the request is understood by the server, it is successful. So server sends the file to the browser, and then browser displays the file. So we never see 200 OK. That is in the underlying message that is there, but we as a user don't see 200 OK. So anyway, we have finished here, and then today we will start from the next section. Okay, one thing we have mentioned in the last class, if you can remember, that is HTTP is stateless. Can you recall that? HTTP GET response interaction is stateless. Can anybody tell me what is stateless in short? What is stateless? Anyone? What is meant by okay, what is the meaning of stateless? Stateless means there is no storage of state. So either client or server, they will not store the information about the current connection situation. That is stateless. Now why that happens? Because HTTP was initially defined to be simple. To make it simple, there is no state information. For example, if you click a save file, you want to save a file, you clicked 5 or 6 times, maybe after a certain amount of time, 5 or 6 times the save as window will appear, right? I have given this example yesterday. So this is one example of HTTP is stateless. That means HTTP will not relate current request with the previous one. So if you request a file 10 times, HTTP will send you the file 10 times. But now consider an e-commerce, right? I think many of you now use e-commerce. You buy products from different websites. This is very common now, especially in this pandemic situation, COVID situation. Online interaction is grown up, right? So there are so many websites. For example, rockomary.com. Anybody in the class use rockomary.com to buy books or any other products? Anyone? No? Okay, fine. No problem. Then there are so many.
Yes, sir.
Yes, right? So I think many of us used that. Rockomary.com is a good website to buy books. But also there are many other sites to buy online, even for our accessories. Like there is a chaldal.com for the daily needs. So there are so many websites, e-commerce sites now available. And now HTTP, how you access that e-commerce site using web browser, right? So HTTP is stateless, but just think about, you have opened different window and you have selected different products, and from any of the window you click checkout, right? When you click checkout, then all the products are there. Did you notice that? Even if you use multiple windows, right? In the checkout, they actually collect all the products, and every product you have selected, for example, maybe you have selected from different windows, right? You got my example? Yes or no? Did you experience this? Now my question is, HTTP is stateless. How you got different products selected from different window of the same website, definitely of the same website, but when you check out, you got all the products in the same window, right? If you buy 10 books all in the same window, it appears. How that happens? Just think how that happens. We need a mechanism on top of HTTP, or using HTTP, we need a mechanism to make it stateful. To make it stateful. So one of the mechanism is cookies. I think many of you have heard this name, cookies, and now all authenticated pages, even websites, authenticated pages, whenever you go there for the first time, then they give you a window, right? These are our policies for cookies. You have to accept the cookies. You have to click accept. And in some cases, if you don't click accept, then it will not appear. Anybody face this?
Yes, sir.
Yes. So it's very common now. All the authentic websites also use this. It was not like this before. It was not mandatory before, but now almost they made it mandatory. So cookies is one mechanism to make HTTP stateful. Now, why we need a stateful? Consider that e-commerce example. Doesn't matter, I open 10 tabs, 10 different tabs of the same website, for example, chaldal.com. Sometimes what happens, we open a page, a different page. That means same website, but we open a link in a different tab, right? So why? To see what are the products available. Then you see, okay, add to the cart, add to the cart. Maybe from 5 different tabs, you have added differently. But whenever you click checkout from any of the tab, and also you can observe whenever you refresh, every tab will be refreshed. You are not selecting all the products from the same web page, same tab, but still, if you see the checkout box, right, there is a message box. Then when you see there, you will see there is a updated. So you click checkbox, all the products are here. How they do that? Cookies is one mechanism. Now, for example, see this client and server communicating. Okay, so client is sending some instruction to the server. Server is doing this, like lock data record X. Server will lock data record X. Update data records X prime. Server will update data record X prime. Like this. So every instruction is going separately. Since HTTP is stateless, everyone will be treated as a different one. Now what will happen? Like this, instruction is going and server is doing. What will happen? There is a time, you can see there is a time T prime. If during the T prime the server crashes or the client crashes, what will happen? That is the question. Whenever next time you access to the same website, the question is, the previous instructions will be there, yes or no? What do you think? The changes made by the clients to the server, will it be available after I restart or re-access the site?
Yes, sir.
Yes or no? Yes or no, it must be either yes or no. Actually, if we use basic HTTP without cookies, the answer is no. Because server will not store any state. So server cannot detect, okay, this user has done 2 instructions previously, now giving the 3rd one. So everything you have to do from start. Got the point? But if we use cookies, what cookies done, how cookies work, see, what are the steps? We know request and response. So client sends a request, server sends a response. So whenever, let me see an example first, then come back here. Whenever a connection is established, there is a file stored in the client side that is called cookie file. And then all the cookie information are stored in this file, but that is in the machine where I run my browser. For example, in this case, this client, or maybe I previously accessed eBay. You know eBay? This is an e-commerce site in UK or in USA. I'm not sure whether this is available in Bangladesh, but some of the e-commerce sites are even available in Bangladesh now, Amazon and other. They have at least registered, maybe sometimes later they will be available. So anyway, suppose a user has accessed eBay before. So when accessed, eBay created an ID like 8734 and sent the client. How that is done? That is done by this way. There are 4 components, 4 steps to work cookies. First step, cookie header line. You know header line? In the request and response message, we had a set of header lines. If you forgot, let me show you. See, in request message, there are many header lines. I have explained some of those. That header lines actually send information for the server, from client to the server. Similarly, when server sends a response, the header line contains some information for the client. And one particular example we will need is last modified. So we said that server sends the requested file at the end of response, and there is one header line, you can see last modified. That means server is saying to the client, okay, the file I am attaching here has the last modification date this. This we will need. So all the header lines are used by the client to take information from the server. Anyway, so whenever we use cookies, that means an extra header line is added both in request and in response. So the first step is a cookie header line in HTTP response. Since server instantiates the cookies because server wants to identify the user. So server will create a ID for the user and add that ID in the cookies header when it sends a response. And then for all the subsequent requests sent by the client will contain that ID. Now it is clear, every time my browser specifies that ID in the cookie header, then server can identify, okay, this is the user, because server stored that ID in its own database. So server can identify the user. That is the idea. Now server can relate all the activities of the client. Cookies file kept on user's host managed by the user's browser. So whenever I open the browser and click the site that I have accessed before, my browser will open the cookie file, see whether that ID is created there, then send the ID to the server. Server can identify myself. Not only that, server can contact its database to identify what I like. For example, server can send me some suggestions for book. Maybe I like networking books or I like programming books. I have bought 3 books on programming in the previous week. So after 1 week, I have entered the same website. Now the website can suggest me some books. Okay, you can see these books on Java because last week you bought some books on Java, so you have interest on Java. So similarly, all e-commerce sites, they actually suggest something. How they can relate myself? How they can identify myself? Because that ID is created in the server side, and every time I access to the website, my browser sends my ID, so that server knows who I am. Right? So that is the idea of cookies. And the example I am giving here. So suppose in the cookie file, right now, there is only one entry, eBay, but maybe for the first time, I have entered Amazon web server. Amazon, you know Amazon in USA, UK. Amazon is a worldwide company that provides e-commerce service. All kinds of goods this provide. So suppose for the first time, enter. Now the HTTP request contains nothing, normal. But what the server will do, if the Amazon server uses cookies, the Amazon server will create a ID for me, for this user, right? For example, maybe it is 1678 and store the ID in its own database and send, see, when it sends the response, it will add a new header. There are many other header lines, but it will add a new header line that is called set cookie. And it will then give the ID there. What happens? Now the client browser will update its cookie file. Now it will add Amazon also there with 1678. Okay. So next, for all subsequent requests, there will be a new header line, cookie 1678. That means client will inform the server, see, this user's ID is 1678. So every time the user accesses and does some activity, everything is recorded in the server's database. For example, after 1 week, the same client access to the server, right? Again, cookie 1678, because this cookie file contains the data. Now server can relate, okay, what you have done 1 week before. Server can do whatever the server wants. Maybe can suggest some new goods, can give some offers, discounts, okay, anything. So what we can see here, using only one header line, a header line can implement an entire mechanism of cookies. And now HTTP can identify. Now HTTP is stateful because every time it can identify who is accessing. Clear? The example clear? Any question? Anybody? Nuzhat, Shomik?
স্যার
Yes.
যে হেডার লাইনটা মানে কুকিজ যেটা আমাদের রিকোয়েস্ট করে এটা তো আমাকে ওই আইপি অ্যাড্রেসটার উপরে করে দেয় না?
Okay.
না আমি যে ডিভাইস দিয়ে মানে রিকোয়েস্ট পাঠাচ্ছি ওইটা মানে ওই আইপি অ্যাড্রেসটাকে মার্ক করে রাখে হেডারটা যেটা অ্যাড করে।
No, there is no IP address. See, now we are in the application layer, right? we are now in the application layer. IP address works in which layer? Which layer? Network layer, right? IP address works in network layer. So when my application creates the HTTP request message, then it hands over to transport hands over to network. So that is the concept. But now we are talking only about communication between client and server at the application level. So that's why, again, let me go back to the format. See, there are some header lines already, but there is no cookies now. That is defined in the HTTP. Whenever you want to implement some mechanism, you have to use this header line. So for cookies, you have to add another line here, that is cookies, if there is an ID for that particular website. Similarly, for the response message, for the first time, server will create an ID and will add a new header line, set cookies, and then give the ID that is created. Is it clear now? So when I say this, actually these header lines are part of request and response message. Is it clear?
Yes, sir.
So that you have to just think about the request and response now, not any other thing. So just we are adding a particular header line, and we are implementing an entire mechanism of cookies.
স্যার হেডার কুকি যে হেডারটা আমাদের দিচ্ছে ওই যে এইচটিটিপি রিকোয়েস্টের সময়, তো এটা কি মানে আমি যদি ডিফারেন্ট জায়গা থেকেও যদি আমি সার্চ করি বা কিছু করি, তখন তো কুকিটা কি সেমই থাকবে নাকি আমার ডিভাইসের সাথেও সংযুক্ত থাকে?
It will be different. ID will be different. First thing, ID will be different. Okay, before ID, if it depends on the server. Is the server creating cookies? That is the question. See, I said when you go to IEEE website, when you go to some authentic website, they now forcefully send you to accept cookies. So it depends on the server. I go to different server that doesn't actually use cookies, then there will be no cookies. So it depends on the server. If I access 10 different websites, all uses cookies, then probably there will be 10 different IDs stored in my cookie file, right? Clear? Yes or no? Okay. Any other question? Anybody? Today's attendance is very low. Why? What do you think? Is it also in other classes too? Because I can see.
Sir, for makeup class.
Yes, but makeup class is same important as your regular class. Only 26 out of 50, so it's almost 50%. Anyway, this is an important class. Okay, any other question, anybody? So this is the idea. Just try to understand this example, how cookies are. But I think the mechanism of cookies is very simple. Server will create an ID, inform that ID the browser will store that ID in a cookie file, and then every time I use the browser, if I access the same website that has created the cookie, the same ID is sent to the web server. Web server will do whatever web server wants. Okay, so why cookies are used? I think we already know what is the logic, but it can be used for different purpose. For example, authorization to identify the user. Okay, then as I said, e-commerce, shopping carts, then to provide some recommendations. Why they need to identify me? Because they want to give me some recommendations. It can be different products, it can be offer about different products, so for this. And then it is also used to trace user session state. For example, we all use web-based email, right? Sometimes what happens, if we are inactive for a huge amount of time, then I am getting my session is expired, so I have to re-log in. So for all this purpose, cookies are used. But we know we can also use another option, that is the registration. So you have to register. For example, in email case, you have to give register, and then you will get a username and password. And then when you access through that username password, then that is a separate mechanism. Okay. But one challenge is how to keep a state. In some cases, protocol endpoints means actually if the protocol works in end systems. For example, application layer works in end systems, transport layer works in end systems. So end systems can actually store the state. For example, if we read TCP in chapter 3, we'll see there is no cookies there. So every end system will every transport layer in an end system will store the states of the other side. How? Using the header. But in this case, we are defining cookies. Cookies is actually an application layer mechanism that HTTP messages that enables HTTP to store the states. But there are some disadvantages also. You have to be careful about cookies, because cookies can also, it can also be abused. It can also be misused. Like you have given some information, you don't know your information is going where, right? So it sometimes violates the privacy. Although the authentic and well-known websites, they use cookies for good purpose, but some other websites can use cookies for bad purpose. So whatever you give, whatever you accept for cookies, you have to be careful, because your data, your confidential data, your sensitive data can be steal by some third party, and they can sell it to the other parties in the underground also, right? So cookies can be also used for mail, I think, bad intention. So that is the downside of cookies. Okay, next concept is web cache or proxy server. I think many of us has heard about proxy server, right? Anybody heard about proxy server?
Yes,
Sir,
Anybody?
recently
Yes, sir.
BTRC closed proxy servers from ISP.
Okay. So do you know what is the basic purpose of a proxy server? Just in case, if you don't know, no problem. Anybody knows about what is a purpose of proxy server? You know the meaning of proxy, right? Proxy means to pretend to be someone else. But proxy server is used in a good intention. That means if you browse internet, for example, in a LAN, many users are there. So users actually browse internet. And in this case, if every time we need to go to the original server, then what will happen? There will be two disadvantages. First one, it will take time, right? If the file size is larger, it will take more time, because every time I have to go to the original server. Second point is the original server will receive more and more requests. So that will bog down, that will be burden, overload the original server. So what the proxy server does, you can see the diagram. What is it actually works as a middleman. If you see this again, the original client sends a request, and when proxy server is set, that is called web cache. That proxy server can have a large cache, and it will be set in such a way so that normal clients will be passed through the proxy server. Normal client cannot directly go to the original server. So what proxy server will do, it will receive the request, and it will, on behalf of the client, it will send the request to the original server. But once original server sends the response, you can see here, it will send the response to the original client, but at the same time, it will store the web page in its web cache. Did you see this? So the same page is also stored in the memory. What will be the advantage? Next time, another client, same client or another client, requests the same web page. See, that is available to the proxy server. So it will not forward to the original server. It will send the page from its memory, from its cache. So that is the idea of web cache. Now, two advantages. The previous two disadvantages, if there is no proxy server, if we use proxy server, these two will be advantage. One is client will get response in less amount of time, right? Definitely. And also the servers in the internet will be less overloaded, right? So 2 points are here. Did you get the idea of proxy server or web cache?
Yes, sir.
Okay. Actually, proxy server is a physical server that is placed in the local area network, in a organization's network, or we all use internet, right, from some ISP. So ISPs also maintain some web proxy servers, so that ISPs support many users, right? Thousands of users, millions of users. So they actually store some of the information so that every time they don't need to go to the original server. So that will actually increase the efficiency of their service. But web cache can be also part of our browser in my own machine, like in the original client. My machine is a client. I am using a browser, but browser can also save something. It is also said web cache. So web cache is not only related to proxy server. Proxy server normally will use all kinds of materials stored for all the users in the network, but every user's browser will also can store some temporary files. We can call that also a web cache, right? So the goal is to satisfy the client request without involving the original server. How it works? Very simple. If client sends a request to the web cache or to the proxy server, then if the object is in the cache, cache returns the object to the client. Don't need to go to the original server. If it does not, then it will send request to the original servers. Okay. So if 40% of the cases we don't need to go to the original server, definitely that is a big improvement, right? Now there can be one problem with this. One problem means one challenge we have to deal with this. Anybody, any idea? What can be a possible challenge or possible problem we have to deal with if we use web cache or proxy server? Updating, right? How we can make sure the file stored in the web cache is the latest one, the updated one. If client gets the old one, there is a latest updated one, then client will not be happy, right? So how can we ensure that web caching gives the clients the updated requests, right? So that is one thing we have to keep in mind. I am giving you the solution shortly. Before that, let us understand a little bit more. So I have already said that web cache actually acts both as client and server. So if you see there, the proxy server acts as a server for the original client, but proxy server itself acts as a client for the original server, right? Agreed?
Yes, sir.
So in this case, this web cache or proxy server actually acts both as client and server simultaneously. And typically the cache is installed in ISPs, internet service providers, or the organizations like UIU, university, company, or residential ISP. And why we have used web caching, I think I have given the solution already for two purposes. One is giving service in less time to the clients and reducing load in the internet or on the server. Let us get a more visible concept using an example here. We will do some hands-on examples tomorrow in the next class. Today just we will describe the example to understand the concept, so that our hands-on, when we do hands-on, it will be easier to understand. This is a scenario where we want to see the utility of caching in a numerical way, okay, in numbers. So there is an institutional network. For example, this is UIU network. So institutional network is connected to the internet through some ISP, right? So there can be many other routers, but one router called border router from the institutional network is connected to one router in the ISP. ISP can contain many other routers, but one router actually connects to the institutional network. So this link, you can see the link between institutional border router to the ISP border router is called the access link, because through this link, all the users access to the internet. Up to ISP's router, all are internal, right? Local. But from ISP, internet actually starts. Also, another observation here, you can see the local area, in the local area network, all the hosts has LAN card, and LAN cards has different speeds. I think probably if you search or if you just check what is the speed of your LAN card or transmission rate of your LAN card, you will see probably 100 Mbps, that is fast Ethernet. And more common nowadays, the technology has improved, so it's 1 Gbps. 1 Gbps means we call it gigabit Ethernet. So your LAN card maybe supports 1 gigabits per second. That means 1000 megabits per second. See, what is significant here, the access link is the bottleneck. The access link has only 1.5 megabits per second. Okay, it depends on how much bandwidth an institution rents from the ISP. The more bandwidth it will need, the more cost it will be involved. Okay, so for example, institution rented only 1.54 megabits per 54 megabits per second. Now you can see this is much less compared to the local area network. 1000 megabits per second. Whenever you connect a LAN card to your switch, to your router, it is 1000 megabits per second. Whereas from my institution's router or my ISP's router to another, it is only 1.54 megabits per second, much less, right? So that is the point. If we can save, if we can store a web server here, sorry, not web server, proxy server here, like a web cache, then many times we don't need to go through to the internet, right? So in that case, that will be useful. Now in this example, we can find out, for example, it is assumed that RTT, do you know, can you remember in the last class I have mentioned RTT. What is RTT? Round trip time, right? So sending a small packet from client to server and then server to client, this round trip time is called RTT. In this case, this is assumed to be 2 seconds. Okay, so there are 3 times involved. You can see there are 3 times end-to-end delay. That means if from one host I access to one of the internet servers, there are 3 types of delays. First one is LAN delay, local area network delay, right? From PC to my border router. Then my border router to the ISP, that is the access link delay. And from the ISP router to the final server, that is the internet delay, right? Understood? Any questions so far? So we can divide into 3 types of delays. Now, this is local network has 1 Gbps, so very high speed. Access has only 1.54. So if you calculate, we'll show one example tomorrow. If you calculate, then you will find out LAN utilization is 0.0015. Why LAN utilization is 0.0015? Because all these host has 1000 megabits per second capacity, although they can use only 1.54 if they go to the internet. So if I want to show you the utilization of every local host is access link capacity divided by LAN capacity. So what is the access link capacity? 1.54 or 1.5? For we just write it 1.5. And what is the capacity of the LAN? Can you tell me? 1 Gbps, right? 1 gigabit means what? 1000 megabits. So if you divide this by this, we can get 0.0015. What is 0.0015? Because although they has 1000 megabits per second rate, they cannot send more than 1.5, right? So that is the problem. We have high power in the local area network, but because of the link, access link, that is a bottleneck, we can get less available bandwidth. When we read throughput, can you remember in chapter 1, that performance parameter we read throughput, and we said the minimum link bandwidth will determine the throughput. So this is related with that. We will get only 0.0015. So LAN utilization will be much less, although the power is high. And if you just think about, there are some representative values given. If we think about internet delay, that is, for example, 2 seconds. If we think about that access link delay, then this is minutes. Why minutes? Because all the users must go through this access link. So this will create the main bottleneck link. And what about the delay in the LAN? It's very small. Actually, this is not U. This is mu. Okay, mu means what? Microseconds. Okay, so LAN delay will only be microseconds. So it is very much negligible. In the other sense, we cannot take advantage of LAN because of what? Because of that access link. Okay, and access link will be occupied most of the time, but it still will not get that much. What is the solution? The solution is putting, okay, one solution is, okay, one obvious solution is very good. Increase the access link capacity, like from 1.54 to 154. We can do that. But what is the problem with that? Anybody? If UIU wants to, okay, increase the capacity of the access link with the ISP, UIU needs to rent more and more bandwidth from the ISP, right? So the problem is what? Cost, right? There will be more cost involved. So even if we increase to 154, that might not be enough. Still, the utilization might be low. So that is one solution, obviously. But how much we can increase? That is the question. Even if we can increase, that will involve many more costs. So what is the other solution? The other solution is like placing a local web cache or a proxy server. Now we can calculate the utilization again. We will see that the utilization will be much better. Why? Because some of the materials nodes can get from the proxy server. Every client, every host doesn't need to go to the internet every time. So our utilization will be definitely better. And there are some calculations involved here. The entire example is given in the textbook. Please go through the example, but then we will do one hands-on example in the next class. So the main advantage of using web cache is what? Cheaper. It's a cheaper solution. It's a good solution. And the ISPs mainly give us some options, right? That bufferless YouTube. Did you see that? They say, okay, this is the feature of our ISP. One is bufferless YouTube. What is bufferless YouTube? Anybody?
So no lagging while we play a video.
Right. No lagging. So how no lagging? If every member of the local network tries to access their, there must be some lagging, right? Actually, what ISPs do, they actually store that local servers, and they continuously store those videos in their cache, and their local server, their proxy server is part of their local network. So that is how they give access, and they continuously updates the videos. So that's why as a user, you get most of the videos you get from your local network, and definitely lagging will be not there. So that is bufferless YouTube. Okay. Also, there are some other factors there, but this is one of the examples of using web caching. Clear, everybody? Any question? No question. So all of you understood everything, or you understood nothing? Which one? Are we all awake? Are we
Yes, sir,
listening?
I understand.
Okay,
Yes, sir.
I want more voices. I want more students to be awake. Okay, otherwise I will go to sleep like you. Okay, please try to respond in the class. I feel good when you respond. I don't feel good when you don't respond. So I request more response from your side. I'm also a little bit tired. So if you ask questions, I can have some time to relax. If you don't ask questions, I will continuously go and go. Okay, so how to compute the link utilization and delay? You have to see the example in the textbook, and we'll do some hands-on later on. Okay, how to calculate the link utilization actually depends on some factors, like how much of the what percentage of the web pages I can store in my web cache. It depends on the cache size, it depends on the configuration. But for example, if 40% requests can be satisfied, then 40% of the time, out of 10 requests, 4 times we don't need to go to the internet. There's a big improvement, right? If you say, okay, 60% I can store, then out of 10 times, 6 times you don't need to go to the internet. So that is the idea. But when we do some hands-on, then it will be more and more clear. But please go through this example from the textbook. The entire example is there. That will help us when we do the hands-on. That will help us to understand. So that is the concept of web caching. Okay. Okay. Now, the last concept of HTTP is conditional get. Now we know the get. What is get? Get is a method to request a particular file. Now what is conditional get? Remember, we had a problem in web caching. How we can be ensure that the server, that the cache has the updated file, right? And how can we do that? Any idea? How can we do that? Nuzhat or Mustafa, do you have any idea? How can we do that? Very simple. We can ask the server, right? But how often? How often we should ask the server about the update? Because the file, whenever the file is cached in the memory, next time the file can be updated. You got the point? So this is a challenge. How to keep the cached contents updated. The answer is conditional get. Why it is conditional? Because see the example. Whenever in this case, client is the proxy server. Keep in mind. The original client sends a request to this proxy server. Now proxy server will act as a client because it will search in the web cache, and possibly it it has got that file in the cache. But the question is the file updated one? That is the question, right? So what proxy server can do, proxy server can send a request message to the server, but this time it is conditional gate. How it is conditional gate? Because if the cache has a corresponding file, that means what? That means the file must, the cache must have a version of the file in the memory, and that file has a last modified date, right? So it will send a request to the server saying, adding an extra header line, that is if modified since, and there is a date, that is the last modification date of the file. So it asks the server, okay, I have a version of this file, but its last modification date is this. Is the file modified after this date? If the file is not modified, don't send me the file, only send me the message. If the file is modified after that, please send me the file too. Is the logic clear? So what happens here, see, server says if object or file is not modified, server will simply send, okay, 304 not modified. No file will be, no data will be added because this file is already in the cache. If the file is modified, then what will happen? It will happen. Server will add data or file at the end of the message. Is it clear now?
Sir, when we search for a file and actually it works from cache server, and
Right,
when we search for updated file, the cache stored the older file.
Actually, there is a version of the file, right, in the cache, right? But the proxy server is not sure whether the file is updated later. That is the question. So how?
Yes, sir.
Also,
But-
if the file is not updated, we don't want the file to a server to send the file because that is wastage. Clear? So that's
So
why.
the proxy server will know that the main server's file is updated or not.
Yeah, this is the main server. See, in this case, the server is the original server, and in this example, you can see written client. That is actually the proxy server. The original client is on left. You got my point? So don't confuse this server with proxy server. Don't confuse this client with original client. This client is the proxy server, and the server given here is the original server. You got my point, Mustafa?
Yes, sir.
So actually proxy server is communicating with the original server. Normal original client knows nothing about this. Okay. Clear? So this is how conditional gate actually works. Okay, so that is end of HTTP. Now we will go for email, that is section 2.3. First of all, we all used email, but mostly we used web-based email, right? There are three major components in an email system. One is user agent, one is mail server, one is simple mail transfer protocol, SMTP. This is actually the protocol, and there are other protocols also, IMAP, POP, and HTTP. So what is an user agent? You can see in the diagram, a user agent is actually a software agent. The software we use to compose, edit, or read mail messages. For example, Microsoft Outlook. For example, we use web browser for web-based email. There are standalone softwares for desktops like Eudora, like Pine in Linux, iPhone mail client. There are some in Android phone. So there are different types of softwares for composing the email and sending the email. And also, most of us now use browser to compose and send emails. So HTTP can be also used, but it was not invented for email, but it can be now used. That is user agent. Now, the next component is mail server. every user must be a authorized or authenticated user under a particular mail. So for example, if your email address is abc@gmail.com, that means the Gmail, you are registered under gmail.com. If someone has xyz@yahoo.com, he or she must be registered with yahoo.com mail server. So when we send an email from one host sender to the receiver, then the sender's email server must be connected. Sender must be connected to the sender's email server. And that mail server has two components. As you can see, any mail server has two components. One is the outgoing message queue. You can see the green one, the message queue that contains the message initially, and then the server actually serves one by one. And there is another one, the yellow box. You can see the yellow boxes in each mail server is the mailbox. So actually every user, every registered user has a corresponding mailbox in the server. Okay. And also we have to use some protocols. SMTP is the protocol, simple mail transfer protocol, that is used between email servers to send email. And here, very important, the client is a sending mail server and the server is the receiving mail server. So in HTTP or in FTP, you will never see two servers are communicating, right? But in email, you will see two servers are communicating, because the sender's email server will hand over the message to the receiver's email server to put the message to the receiver's mailbox. So there is no server-server architecture. So in this case, which mail server will be client, which mail server will be server? That is specified here. The sending mail server will be client and the receiving mail server will be server, because sending mail server sends the mail or resource to get to the receiving mail server to distribute the mail. So that is the service, distributing mail to the correct receiver. Okay, so that is the system. Now there are some properties of email. The protocol is RFC. As we said, every protocol is defined in a request for comments, RFC 5321. We saw HTTP uses TCP. Here also SMTP also uses TCP. So that is a similarity with HTTP. And HTTP use port number 80. Now HTTP uses port number 25. That is a difference. And direct transfer, sending server acting like client to receiving server. As I already have said, two mail servers communicate, one as a client, one as a server. And there are three phases of transfer. First, handshaking, and then transfer of messages, and then closing the connection. And all the commands or response interaction is done in ASCII text. That is common to HTTP also. In HTTP also, the commands are in ASCII text. And in HTTP, we saw the response message in status code and status phrase. Similarly, in SMTP also, there are status codes and status phrases, but all the messages must be in 7-bit ASCII format. So you know ASCII format, that is for every character, there is a ASCII code. That means the protocols will be, if we just capture the headers, these are visible, these are understandable, because all are 7-bit ASCII code. There is a very simple example. I have already given an example, but there are 6 steps. Let me describe shortly. First step, for example, Alice is the sender, Bob is the receiver. So Alice will compose the message using Alice's user agent. Second step, when Alice clicks send, then there is a connection set up between Alice's user agent and the Alice's mail server. Then in the third step, the mail server will store Alice's message to the message queue. In the fourth state, Alice's mail server will act as a client and create a connection through SMTP with the Bob's mail server as the server. Step 4, then after Bob mail server and sends the message to the Bob's mail server. And step 5 is Bob mail server will receive the message, and definitely if Bob is a valid user in this mail server, Bob has a corresponding mailbox. So Bob's mail server, step 5, will store the mail in the mailbox, and step 6, Bob will access the mailbox and then read the messages. Clear? So this example very easily shows you what are the steps, how a particular email system works. Any question, anybody up to this point? No question? Very good. And there are some observations. There are some similarities and there are some differences between HTTP and SMTP. First of all, HTTP is a pull protocol and SMTP is a push protocol. Why this concept? Very logical. Because in HTTP, we saw a client sends a request for a file and then receives a request file from the server. So client in effect pulls an object or a file from the server, right? What happens in case of SMTP? See, we see here. In this case, Alice's mail server is the client and Bob's mail server is the server. Now, what is the resource here? Anybody? Is it a file or it's an email message?
Email message.
Email message is the resource, right? So now in this case, Alice's mail server is client, right? And Bob's mail server is server. So Alice is actually pushing the message. In this case, this is right because pushing the message for what? To get a service. But consider it with the HTTP. Client is pulling the file, not pushing the file. In this case, client is pushing the message or email to the server. So that is the difference. Okay. That is why HTTP is called a pull protocol. SMTP is called a push protocol. But there are some similarities also. Both have ASCII commands. Both have code and response, status codes and phrases, response phrases. Then there is another difference. In HTTP, each object encapsulated in its own response message. You will never see HTTP to send more than 2 files at the end of one response message. If you download 3 files using HTTP, each of the files will have a separate response message, and at the end of the response message, the files will be attached. So in HTTP, one message can contain what? At most one object. But assume you have attached 5 different files when sending an email. Then what will happen? SMTP will not attach all the files in the single message. What SMTP will do? It will create multiple objects in multiple parts of the message. That is logical, right? Because I can attach any number of files in email. So that is the difference. And then again, there are some similarity. Both SMTP and HTTP sends message in 7-bit ASCII. And in the last part, in HTTP, we saw the end of message is specified by 1 carriage return and 1 line feed. Right? Can you remember? And in case of SMTP, also the same characters, but little bit different. 1 carriage return, 1 line feed, and then there is a dot, then another carriage return and another line feed to indicate the end of message. So these are the some of the similarities and some of the differences between HTTP and SMTP. Clear? Anybody, any question? Okay. So up to the receiving email server, where the receiver has a mailbox, we said what? We said SMTP works. SMTP is a forwarding protocol that forwards the message up to the mailbox at the destination. But then receiver can be offline. So it depends on the receiver how it can read the messages. It needs to access to the mailbox, okay, mail server, to receive the messages. So SMTP can no more work here. So these type of protocols we call mail access protocols, and there are 3 types of protocols listed here. one is POP, Post Office Protocol, one is IMAP, Internet Mail Access Protocol, and one is HTTP. In case of POP, it is Post Office Protocol. So in this case, actually client retrieves the mails from the server and then downloads in its own machine and do whatever he or she wants. In case of IMAP, client will do whatever client wants in the server. So not in the client's machine. It will be in the server, but not web-based. In case of HTTP, still client will do everything in the server, but this is web-based. So for POP and IMAP, you have to configure your machines. But for HTTP, you don't need to configure your machines. Just if you have internet connectivity, you can access your email from anywhere in the world. So that is why HTTP is so much popular as the mail access protocol. But you have to keep in mind, you can also use POP and IMAP, especially when you want desktop-based access to the mails, or you want customized settings in your site. Okay, so these are the basic idea about the mail access protocols. Any question? Okay, so let us stop here. We will not have enough time to complete DNS today, so I will better not start DNS today. If you have any question, I can answer, and then we will complete DNS tomorrow, and then after that we will do some hands-on examples. But you have to keep in mind, the hands-on examples we will do for web and HTTP will also be included in our class test 2. No question? Okay, if you do not have any questions, let me stop presenting here and let me take the attendance.
Sir.
Yes, question?
Sir, CT2 will be held like CT1 also,
Right, online.
online.
Similar type of questions, but as I said, in online questions there can be 1 or 2 questions you have to write in the textbook, text box, and in that case I have to grade those questions later on. So if I give any question like conceptual question, essay type question, you have to write in the textbook, that will not be automatically graded, that I have to grade after the exam. That might be the only change. Okay,
We have to do everything in ELMS, right? We don't have to
right,
get up.
right, like the previous one, everything in ELMS.
Okay, sir. Thank you.
Okay. Okay, so respond quickly, please. I am taking the attendance. Okay, Tanjina Hassan. Tanjina. Azharul Haq.
Yes, sir.
Mushfiqus Salihin. Abu Ammar. Azizul Hakim.
Present, sir.
Mahir Shahriyar.
Yes,
Kamrul
sir.
Hassan. Okay, Mahir present.
Yes, sir.
Okay. Kamrul Hassan.
Yes, sir.
Tanvir Rahman.
Yes, sir.
Ishrat Jahan.
Present, sir.
Anika Tahsin.
Yes, sir.
Shomik Shisho.
Yes, sir.
Nuzhat present.
Yes, sir.
Farhanaj.
Yes, sir.
Okay, Jahara Islam present. Kausar Ahmed.
Yes, sir.
Okay, Munzirul Asad.
Yes, sir.
Enamul Bari.
Present, sir.
Mohammad Sabbir. Mohammad Sabbir. Saima Khanum. Saima Khanum. Okay, one more thing. I think I should not forget to tell you. In the last class test, I have considered some of you had problem with making your video on, but from this exam and onwards, please make necessary arrangements. At least during the exam time, you have to keep your video on. This is the requirement from the proctorial committee. So if you do not do that, I have to answer the questions, and in that case I might not in the long run I might not accept your exam. So please arrange your prior to your class test day, arrange. If someone has problem, maybe you have to arrange your data. If you also take backup for data only the class exam time. So please take it carefully, seriously. Don't tell me during the exam that I have this problem. Okay, that is one thing I have to ensure. Okay, Saima, are you there? Saima Khanum? Saima? Okay, Taufik Hasnain, Shihabuddin,
Present, sir.
Jannat Ara.
স্যার ছিল নেট চলে গেছে।
Okay, okay, Partho Protim,
Present, sir.
Ifat Ahmed,
Present, sir.
okay, Mahmud Hassan,
Present, sir.
Shahabuddin Sadia, Thasin Shahabuddin Sadia. Okay, Shafiqul Islam, okay, Ihsanul Karim,
Yes, sir.
Shariful Islam,
Present, sir.
Saudia Haq,
Yes, sir.
Nuri Nawaz,
Present, sir.
Shoaib Ahmed,
Present, sir.
Mehdi Hassan,
Yes, sir.
Wasiul Haq,
Present, sir.
Samiuzzaman Rafe,
Present, sir.
Adrito Mustafa present, Ashikur Rahman,
প্রেজেন্ট স্যার।
Sultan Mahmud,
ইয়েস স্যার।
Sumaya Akhtar, Sumaya, Rahul Mullik,
Yes, sir.
okay, Noyon Kanti, Noyon, Sadiqun Noor,
Present, sir.
Nafis Mahmud,
Present, sir.
Mia Muhammad Azizur,
Present, sir.
Faisaluddin,
Present, sir.
Nazmus Sakib,
Yes, sir.
Fahim Ahsan,
ইয়েস স্যার।
Moshiur Rahman, Kaji Maisun.
Yes, sir.
Okay, anyone else? Okay, thank you very much. See you tomorrow. We have a class tomorrow. Let us finish today. Okay, Allah Hafiz.
Assalamu alaikum, sir.
Wa alaikum assalam.